Hi class, this is Mr. Watlington, and today we are going to talk about a subject that can be very confusing in the IT world called domain name service, a DNS. Now what domain name service is, it's a way that we can resolve IP addresses to host names. So let's get into this, all right? So when we think about the DNS or domain name service, we have to think about how we can resolve these different IP addresses and host names. So when you think about DNS, all right, think about this as just a huge database. Really, that's what it is. It's a globally distributed database all across the globe that ties together the internet via the internet that allows us to do two things for the most part. It does more than that, but basically two things that I'm going to talk about with respect to this training. All right, so here's the issue. We as humans, right? When we're interfacing with computers or with the internet, we don't like IP addresses. We want to use domain names. For instance, if I want to go to the ECPI, I just want to type in www.ecpi.com, right? And go there. Well, that's great for us humans. However, for computers, they deal in the world of IP addresses. Okay, so in order for your computer to actually connect to ecpi.com, it has to know what the IP address is. Excuse me. So that is the conundrum. How do we convert or how do we resolve a domain name, www.ecpi.edu, to an IP address, 223.185.0.1, or vice versa? That is what DNS does for us every day, okay? So when we think about resolving names, we have to kind of understand what a domain name is. It's something that we call a fully qualified domain name, FQDN. And this is what DNS, by and large, is doing for us. It's helping us resolve a domain name, a fully qualified domain name, to an IP address. So let's talk about this domain name in a little bit more, okay? So when we think about this FQDN, or a fully qualified domain name, it is the complete name that's used to identify a node or host within the DNS namespace out there on the internet. All right, so when we think about this, every domain name can be no longer than 63 characters. So where do these domain names come from? Great question. I'm glad you asked that. So let's take a look at this. Actually, you can go on your home computer or your laptop or whatever device it is, and it has a computer name. For this example, this would be the computer name. So actually, if you went into your actual computer, you'll see that it has the computer name. Now, the full computer name is going to be that plus the domain that it's on. So this FQTN is divided into basically two parts. Okay, the host or the node name and the domain name. So this computer, VBCH-W Fuller, is the host name. It resides on the .ecpivab.edu domain. So these two pieces together, the computer name and the domain name, makes up the fully qualified domain name. So that's what that is, two parts. Okay? Now, we also have within this hierarchy, we have a lot of different types of servers. It's important to understand the differences between these different types of servers. First of all, at the very top of this structure, excuse me, we have our root DNS servers. Now, this is 13 servers that's across the globe, across the internet, that they're tied together, and really what they do, they act like giant phone books. What if, yeah, well, you guys probably don't remember phone books. Am I dating myself again? Back long ago, in a distant time, yeah, we used to have a phone book that you could look up, and it had yellow pages, and in those yellow pages, you could find a business name, and it would correlate that name to a phone number. Really, that's all DNS is, like the old phone books we used to have. Or you could look at my name, Larry Watlington, and then a little dotted line, and it would translate, or it would resolve my name to a phone number of 421-3850, whatever it may have been at the time when we had phone numbers. But DNS is doing the same thing. Now, these 13 servers, they are the ones at the very top level that they start this search process to looking at how to resolve a name to an IP address. Now, how they do this? Because if you can imagine, think about how many businesses, companies, individuals across the globe that have or websites that have IP addresses that have to be resolved. So this is a massive undertaking. So these 13 root level servers, they talk to the next level of servers, which are top level domain servers. Now, what these do is they kind of indenture down to the next level. And actually, I've got a PowerPoint in the next my next slide talks about this a little more graphically. Hopefully, you'll be able to see it. But these find these, and these give us a little more information, a little more granularity of what you're looking for. And then from there, it drills down into the second level DNS servers that even now provides even more granularity. And then we're now able to talk to our local DNS server that's able to talk to our computer or our client itself. So different types of servers, so root servers, top level domain, second level domain, and then our local DNS server. So here's a graphical view of what I'm talking about. Okay, this is your distributed database. So here at the very top, right, that dot, we call it, like we think .com, whatever. The dot is the high level. The dot is the root domain, just the dot. So when we're looking for something, we'll go to that dot, that root, and then that is what starts the search down through the hierarchy. So the next level domain below that are where we get the .com or .net, .org, .gov, .us, .edu, all those different dots. Those are the top level domains that we're talking about. Let's say if we can use any of these as an example. Let's just use Cisco. Okay. If I was looking for Cisco's, my computer was looking for Cisco's IP address, it would go to the root and say, hey, root, I'm looking for cisco.com. And root goes, okay, look in the .com, and that's where I'm going to send you to. That's the top level domain. The top level domain servers go, Cisco, yes, we know Cisco, and it sends me to Cisco. Then when I get to Cisco now gets me to second level domains. Do you want to go to our tools site? Do you want our website, the www? And it can just keep indenturing down farther and farther and farther. So you see, that is the second level domain name servers work. So the root is the dot. The top level are the .coms, .govs, .edus, .orgs, or whatever it may be. And then once you get into that organization, then you get the second level domains that now starts breaking down the websites or the addressing structure within that organization. Now, this process starts, though, really with us locally, with our DNS client. And then when I say this word client, think of that just as your home computer or your host machine, okay? That's what we're talking about. So your DNS, your home computer has a resolver, okay? That's what we call a resolver, where it's going to query, it's going to go on, first it's going to look internally, because actually there's a database that it stores or cache inside of your computer that once it knows what that it has resolved a domain name, it keeps it in cache so you don't have to go out and look for it anymore. No different than back in the phone book days. Once you looked up somebody's phone number one time, you would write it down on your little notepad or your cache. And that way you didn't have to go back to the phone book every time you wanted to find that person's phone number. It was in your personal address book. Well, your home computer does the same thing. It has cache in there, or memory, that it will store domain names and IP addresses that is found out about. So this resolver, this is where it starts at. So if that's what actually starts the query process, is your local resolver. Now your DNS resolver is going to query normally the local DNS server, which is typically, for most of us, that is our internet service provider. Okay, your internet service provider will provide you DNS services. Okay, that's or a local DNS hosting. but you don't have to use that. So for instance, this is a Windows example. You may have seen this screen, right, where you can go and look at your TCP/IP. You can pull this up like based on your IP address. Now you can have it configured, like most of us probably are. We're configured where it will automatically um, look for a DNS server. And when it does that, it's gonna go back to your internet service provider. Your internet service provider is going to provide that access. But you don't have to do that. You can actually, there are other types of manual DNS clients that you can use out there, or DNS services. For instance, I use Open DNS. Because so what I do is I click on this button to do it manually, and you just load in the IP address of, let's say, Google. Google runs its own DNS service. Cisco, Open DNS, it runs its own DNS server. You may say, well, why would you want to do this? Well, here's why. Because with with just a standard getting DNS from your internet service provider doesn't give you a lot of options. It doesn't really give you a lot of querying as far as you to be able to go and look at what type of DNS activity has been going on. Use an open source DNS resolver like Cisco Open DNS or Google DNS, and these are the actual IP addresses. So you can actually use these once you set up an account with Open DNS or Google DNS, and you would just type those IP addresses in. But what it gives you though now is a lot more information about the DNS activity. So that way you can, from a security or from a cybersecurity perspective, you can see if someone else has been trying to get in and out of your system via the DNS protocol. It also shows, where names have been resolved and what type of activity goes on back and forth. So those are some things you can do by using an open source DNS resolver. Now, so we've talked about the servers, we've talked about the client sides, and let's talk about two other pieces, DNS zones and records, okay? There are basically two types of DNS zones. A forward lookup zone. And what a forward lookup zone is, that's where we're going to try to resolve a fully qualified domain name to an IP address. That's what's done probably most of the time across the internet. Excuse me. A reverse lookup zone, okay, what we're doing there is just the opposite. We're going to resolve an IP address to its corresponding fully qualified domain name. Okay, so two types of lookups: a forward lookup and a reverse lookup. Now, how does this all happen across the internet? Right, well, it's done with records. Okay, or a file. Basically, DNS has multiple types of records. Well, I'm just going to talk briefly about four, really two. Okay, so when we look at records, there's one type that you're going to see probably most of all is an A record. An A record, that's used for IPv4, right? IPv4 uses an A record to map host names to the IPv4 address. If you see the 4A AAA record, that's IPv6, okay? That's the protocol, that's the message that goes back and forth across the internet between your computer and all these different servers, and that's how it's transported. Now, DNS is also used for mail, right? When we're using different types of mail, like POP3 or IMAP email, like Gmail and some of these other types of internet mail. Well, guess what? DNS is in the background, even with the Microsoft Exchange, and it has an MX record, and that maps a domain name to a list of mail servers on that domain. That's how we're able to get mail traffic, email traffic. And then there's a pointer record, like I say, and what that is, like I say, it points to a canonical name. All right, and that's the most common used for reverse lookups, or how we would do this, meaning that it's going to look for a name and then do an IP address and then look up the canonical name for that IP address. But really, for the purpose of this class, these are the two records to be aware of: is the A record for IPv4 and the AAA record for IPv6. Okay. All right. So now let's walk through a scenario. Okay. I think this will hopefully bring it all together for you. So here's my computer. All right, I'm sitting in front of my computer, or my client computer. That's what we call it in the DNS world. And I want to connect to www.ecpi.edu, right? So what happens? Like I say, this computer do not have a clue what that means. It operates with IP addresses. So what it has to do is a query. Okay, the first thing it's going to do is look internally and go, do I know who that is locally? And the answer is no, never been to ECPI before, so there's nothing in cache locally. So what is it going to do? Now it's going to go to your internet service provider's local DNS name server, and it's going to query that and say, hey, I'm looking for www.ecpi.edu. And then this is your local internet service provider's name, the DNS server, and it's going to say, well, I don't know. So what is it going to do? It's going to go out and query one of the root DNS name servers, the dot. Okay, so it's going to ask this computer, it's going to ask this server, hey, do you know who www.ecpi.edu is? And this root service goes, well, no, I don't. But here's what I can do for you. Okay. I can send you to, since I do know it's .edu, I can send you to the .edu top level domain name server. Boom. And that's what it does. So it says, okay, go look here. So now that guy goes over here and asks, hey, top domain names, top level domain servers. I know I'm on the .edu. I'm looking for ECPI. And this server is going to go, okay, well, I think I know. It replies back and says, I tell you what I do know is how to get you to the second level domain name for ECPI. And that's the second level. Now at the second level, it says yes, because ecpi.edu, it controls www.ecpi.edu, it controls vab.ecpi.edu, as well as it controls Greenville or grvl.ecpi.edu. And now it says, okay, guess what? I know what the IP addresses are for those locations. For ECPI for the website, there's the IP address. For VAB ECPI, that's the address. And for the Greenville site. So now that second level domain name server sends that back to your internet service provider's DNS server. And that DNS server looks like a hero to my computer because it says, ha, don't worry about you. I got you. So it sends the IP address 23.185.0.1 to my computer. Now my computer's happy. It says, I have resolved www.ecpi.edu to IP address 23.185.0.1. And then from there, it goes out and, it's happy. And now I can get to the website. So you see how many handshakes happen every time. Now, you go to a website that you haven't been to before, or to a site, or now what's going to happen here locally in the cache on my computer is going to store this IP address and that's resolved with ECPI.edu. So that way, the next time I go to ECPI, I don't have to do these handshakes because 23.185.0.1 is stored locally here in cache. But yeah, that happens every time. So you see, DNS is a very useful protocol, extremely useful protocol that is moving across the internet all the time. I mean, millions and millions of these records. This whole thing was done with an A record, right? That was moving back and forth to make this work. Now, something I'm not going to get into deeply here, but is from a cybersecurity perspective. Think of it this way. Let your mind wander a bit and think about some of the, since DNS moves freely across the internet, and DNS writes on a protocol, on a TCP port 53, which means that all the firewalls on all these servers has to be open so that it can accept, the port 53 has to be open. So now if you think about this, excuse me, that is a huge vulnerability, because now we have an open port, open network across that. If I'm a bad guy, now I can kind of get in there and play around with that A record a little bit, and I may be able to do some damage because your firewall isn't going to stop me because it says, hey, it's just port 53. What? DNS? Come on in. Come on in here. So you see, there's a lot of good that DNS does. As a matter of fact, if without DNS, we would be like the phone book. We would have a long list of IP addresses that we would try to have to remember every time we want to go to a different internet or a different website or a different host. DNS allows us to do this without having to remember a lot of IP addresses. But at the same time, it opens up or it induces risk, threats, and vulnerabilities. All right. So, questions? Any questions on that? Oh, and yes. So you're telling me if I can control DNS, I'm in control of my internet. Pretty much, yeah. Because DNS is moving across there all the time. So like I say, this is just a pretty high level view of DNS, hopefully to help you understand that a little bit better. What did we talk about today? We talked about the different types of servers. Well, actually, first we started talking, we open this up with understanding domain name resolution, how we resolve an IP address to a fully qualified domain name or vice versa. We talked about the actual what is a fully qualified domain name, which is the computer name plus the domain that it's on. So that's how you can separate those out. Then we went through the different types of servers, right? From the root server, to the .com or .edu, which is your top level domain name servers, all the way down to the second layer domain name servers, your ecpi.edu or cisco.com. We went through those different things and we took you through a short walk, a short scenario. And we talked about the records, right? A record, that's what's used to to do domain name resolution for IPv4 addresses, and the AAAA record, I just said 3, didn't I? AAAA4 record is for IPv6. All right, guys, hope this helps you out. Have any questions, you can reach out. Have a great day.